Welcome to Resilience in Action podcast. Today I'm joined by Prannoy Suraneni. He's an assistant professor in the Department of Civil and Architectural Engineering here at our College of Engineering at the University of Miami. And he's also a Climate Resilience Institute faculty affiliate. So welcome, Prannoy. So let's just start from the beginning. Set us up a little bit. Talk about yourself and your research and what drives you.
Fantastic. Yeah. Thank you for having me, Michael. Super appreciate it. So, as you said, my name is Prannoy Suraneni. Actually, an associate professor. I did manage to get promoted, so associate professor
Congratulations.
in civil and architectural engineering here at the College of Engineering. So, originally, I'm from India. I lived there for the first 21 years of my life or so. My undergraduate was at the Indian Institute of Technology, Madras. That's in Chennai. So when I finished that, and that was in civil engineering, when I finished that, I moved to the US, so to the University of Illinois, where I did my master's. Once I finished that, my PhD was in Switzerland, in ETH Zurich. And then I did a postdoc for a couple of years at Oregon State University. So in 2017, actually right after Hurricane Irma, I think it was, I moved here. So about 8.5 years ago. And as you can imagine, I mean, Oregon, Miami, it's about as different as it gets. And I've been there, I've been here in Miami since 2017-ish. My work is primarily on two different topics. One is coastal infrastructure, and the second is supplementary cementitious materials. And we'll get into them a little bit more as we talk about. Uh, I lead a group of about 9 PhD students, and it's been fantastic here working with all of the various departments, colleagues, and CRI.
So let's get into the materials and the coastal infrastructure work. Describe a little bit more what those things mean to a lay audience.
Okay, so the first topic I mentioned I'll talk about is supplementary cementitious materials. So most people are surprised when I tell them I work on, the details of concrete. Why would you do that? Who cares? So the reason you should care is that we make about 20 billion tons of concrete every year.
We being globally.
Worldwide, yeah, worldwide every year. So I think that comes out to about several thousand pounds of concrete per person every year, right? And that's an incredible amount of material to make. It's the second most used material in the world. With that comes, unfortunately, lots of CO2 emissions, lots of consumption of natural resources, and a huge economic footprint. So, in simple terms, what I'm trying to do is I'm trying to make concrete better, which is a very broad term. But typically, we are looking at the sustainability and the durability of concrete. So people always get these terms, sustainability, durability, and resilience, kind of mixed up. We can get into the details if we want, but we're trying to reduce the CO2 emissions associated with concrete production. We're trying to make the concrete last longer. And we're generally trying to use products that would otherwise go into landfills. So to get into a little bit more detail, right? Largely what I'm really interested in is these materials, supplementary cementitious materials. They are amorphous calcium aluminosilicate materials. I'm interested in how they can be processed, in how once you process them, the properties change. So this is in material science, it's called process structure property relationships. So that's
process structure property relationships.
Process structure property relationships. That's the overarching theme of what I'm interested in for supplementary cementitious materials. But the application of that is their use makes concrete better or more sustainable, more durable, stronger, whatever it is. So that's one theme of research.
Right.
The second area or theme that we work on is coastal infrastructure. And this is something that's much more broader, something that's much more interdisciplinary. It's something that I've only been working on for a few years now as I've moved to It's not something that has been my core expertise, but as you can imagine, I mean, Miami is really ground zero for storms, for hurricanes, for flooding, etc. So we have to protect our coast. I mean, the value they provide is not in the millions or in the billions of dollars, right? It's in the trillions of dollars. So I work with several other colleagues, Landolf, Brian House, Andrew Baker. So some in the College of Engineering, some in the Rosenstiel School. And the areas that we are interested in is next generation coastal infrastructure. So that includes artificial coral reefs, new seawall systems, things like that. A lot of this falls under the category of green gray, so hybrid green and gray infrastructure. And my interests are material related again here. So can we come up with new types of concrete for this application? Concrete that would be lasting longer because it's more durable, concrete that has some sort of synergistic effect with the seawalls, or concrete that is biophilic in some way that enables the growth of corals or the survivorship of corals. So any number of different things with this green gray infrastructure. We're also interested in deployment. For example, you make this really nice piece of concrete. How are you going to get it into the water? We're also interested before the deployment, the production process of it. So very often this is done by 3D printing as an example. So
Very often, traditionally, it was done by casting.
yes,
And what you're saying is now the
now
sort
more
of the
recently, yeah,
state of the art is let's
yeah,
do it 3D.
yeah. And again, there are other ways of doing it as well, but 3D printing is something that we've been quite interested in, as have many other local startups. So one thing that I'm very interested in is the QA QC process or the 3D printing, how to ensure, that things are consistent, how to ensure that we can kind of understand the properties before it gets into the water. So a number of different topics there. I can't claim to be an expert on coastal infrastructure, but it's been fantastic working on the topic. And you know, UM is absolutely great for interdisciplinary research. I can really get into that if you want. It's something that I really like about the U.
Yeah.
So that has really helped me, get my foot in the door on coastal infrastructure.
I want to come back to both coastal infrastructure and interdisciplinarity generally, because I think that is similar to a lot of the challenges that resilience practitioners face more broadly. But let's just talk about the materials. You've had some success with materials. Talk about what that has looked like. Like what are the successes in terms of engineering better concrete mixes?
Yeah. So I'll talk about a couple of different things. One I'll talk about is the really really small scale stuff, and the second I'll talk about is the larger scale stuff. So at the small scale, we have started to really look at what is called engineered supplementary cementitious materials. So to back up, right, cements uh, are the backbone of concrete. They comprise about 15% of the mass of concrete, but they contribute to about 85% of the CO2 emissions. So cutting down on cement is a great way to make the concrete more sustainable, but it has other benefits as well. Typically, it also makes the concrete more durable. So, I mean, we said these terms are sometimes used interchangeably, right? So, sustainability is generally meeting the needs of the current population without compromising the needs of the future population. Sometimes simplified to just say CO2 emissions, right, or climate change.
Right.
And durability is basically being able to last a long amount of time without, compromising performance significantly.
Right.
So, what we've done is we started trying to understand how you can take any random material that is typically not usable in concrete because the structure doesn't allow it, and how can we actually change the structure. So we came up with a thermal processing method, we came up with a mechanochemical activation method, and in both of these we've had some PhD students working on them, we've had some publications on the topic. Now mechanochemical activation, which is basically grinding it to give it a lot of energy, has really picked up steam, and there are a number of different people working on it. I wouldn't say we were the first, I don't think that's true, but I think we wrote some really nice papers which explain the process well. And there's companies also which are working on it. We've collaborated with some of these companies, try to better explain their process. So I think this is a technology that could take off quite significantly. In the thermals,
Sorry, what,
yeah.
what and what will the outcome of that be? I sometimes shorthand it as low carbon or carbon negative concrete.
Not
But
carbon,
that's
not carbon negative.
not carbon negative.
Well, unlikely.
Yeah.
Low carbon for sure.
Yeah.
But also it would basically ensure a more robust supply chain. It would remove materials from landfills. And in theory, the concrete should be more durable than if using only cement. So
Right.
lots of different benefits.
And you alluded to this before, but concrete is like 6% of global CO2 emissions.
Yes,
something
6
in
to
that-
8% of
something in that
all
ball.
global CO2 emissions are concrete.
Right.
Yeah.
So even a small change could
Correct.
have massive
Even a small
impacts.
change will have massive impacts.
Okay.
And with the thermal activation, actually, we are just about to file full, no, not the full, it's a provisional. We should just about be getting ready to file a provisional patent. Unfortunately, the student working on that has just graduated, so things have been a little bit slow, but there should be IP being filed on that, and that we haven't talked about so much because we wanted to file the IP.
Right.
But that's a very exciting area of research where we think we can significantly reduce the amount of energy needed to make this process happen.
Right.
So that's at the small scale.
Right.
At the larger scale, a lot of work has focused on artificial coral reef and seawall systems.
Right.
Where we worked on is looking at concrete materials for a sea hive, right? But it doesn't have to be sea hive, it can be other applications as well. So we were funded by DARPA, we were funded by the Department of Defense, and we had a few other projects. I wasn't the lead in them, but I was a contributor to them. And we have some interesting findings. So as an example, we see that when you add certain types of carbonates to concrete mixtures, essentially this is in the realm of ocean acidification or ocean acidification resilience. But basically what happens is the coral, so there are 3 parameters of interest when you're looking at the interaction between coral larvae and concrete. One is settlement, so the coral larvae, how much fall on a certain tile. Survivorship, which is basically how many of, out of 100, how many live past X duration.
Right.
And growth, which is what size they get and the rate of that size over time. So we found that this carbonate addition or alkali addition, essentially what it did was it modified the survivorship. We saw actually very significant improvements in survivorship. So this is something very interesting which we are looking to pursue a little bit further. We also did evaluate a lot of other chemistry changes and texture changes as well. The effects, were not that strong, right? But this is an interesting finding. We recently published that with Vivek Prakash as the lead author. And now we're seeing how we can do some field trials on this. And it's of a lot of interest to various companies, for example, and a couple of companies have actually just come to us and said, hey, look, we'll give you some tiles. Can you put them in the water and then try to observe if these effects that you're seeing in the lab can be replicated in the field.
Yeah.
We were not able to do a lot of field testing with this sort of a thing because the DARPA project unfortunately was cancelled because it's a long story and I don't necessarily want to get into that here, but a lot of that had to do with permitting.
Yeah.
And we'll probably discuss that a little bit more, but permitting and policy are like the massive barriers to innovation in these spaces.
And particularly challenging in the marine environment where you have multiple overlapping jurisdictions that get very confusing. So that is certainly something to come back to. Let's just, can I take you back to the low carbon concrete example that you had? So you're close to having something that can significantly change the carbon footprint of the construction industry broadly.
Yeah.
But talk about the challenges for bringing that product to market. Like why it's great in the lab.
Yeah.
But how do we get it so that we start adopting it, and what are those challenges?
Let me talk more broadly. I won't talk about this specific one, but I'll talk broadly about what are the challenges that a lot of these low carbon startups face. So I know this topic pretty well because I've worked with a lot of startups, several of them as part of the tech hub, but others outside of the tech hub as well. So it's a strange market, to be really honest with you.
What's a
Meaning,
strange market?
the low
The-
carbon startup ecosystem or market is very
okay.
strange in the sense, uh, to build a new cement plant is going to cost you somewhere in the tune of $1 billion or something. So the capex requirements are massive, right? And cement, I mean, depending on where you buy it and how you buy it, can sometimes be cheaper than water, right? You do not make a lot of money selling construction materials.
Yeah.
So most of the money that you make is made through volume, right? No one is going to buy cement if it increases even by 15% the price, right? So a lot of the profits, the profit margins are laughably small. You're talking about 2, 3, 4, 5% profit margins, right? So to get investments is extremely challenging, right? Because a lot of people look at this and they go, "Do we really want to invest?" I mean, that's one part of it. The second part is, again, unfortunately, policies, permitting, standards, things like that are very, 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 very complicated.
Right.
Navigating them, trying to get them to change. I mean, there are situations where trying to get a new standard or a specification could take you 10 years,
Right.
right? I mean, that's a ridiculous amount of time to wait for something to happen, right? But of course, I mean, there is a big reason for that, right? So, I mean, this is exaggerating, but for the layperson to understand, the reason, we're so serious about these things is if a bridge fails and if it's a materials problem, I mean, the consequences are horrifying, right? People actually die, right?
Yeah.
So that's not saying that usually happens, but that's the worst case that everyone thinks of
Right.
when something goes wrong with
That's why we need a
materials.
10-year cycle of
Yeah.
proposals, reviews, re-reviews,
Yeah.
public comments, and so on.
It stifles innovation,
Yeah.
but at the same time, you can't just deregulate all of this.
Yeah.
So there has to be some sort of there has to be a happy balance. And we can talk about things like demo projects, etc., which I think are the solution, but they still require money and they require political will and all that. I'm not an expert necessarily on policy and permitting. I'm again getting into it,
Yeah.
and it's honestly overwhelming.
Are there innovative concrete mixes in the pipeline in terms of, or are there innovative policy and standard changes that are in the pipeline that we can see in,
There
I
are.
don't know, 5, 6, 7
There
years?
are many, and actually,
Yeah.
I mean, to give credit, right? So nationally, ASTM is the organization that does a lot of material specifications and standards, right? They've been fantastic. So I'm actually going to an ASTM meeting in a few days, but a number of new specifications have come out in the last few years. So, for example, a catch-all specification for supplementary cementitious materials was recently introduced. So there is a lot happening,
Yeah.
right? Now to get back to the question on why it's so difficult for some of these startups to scale, right? So yeah, you need a lot of capex, you need a lot of opex, you need fairly specialized knowledge. Most investors would rather go somewhere else. The political situation is not exactly what it was, a few years ago. A few years ago, one of the largest ever investments in decarbonization was made by the Biden administration. That was several $1 billion, right? Unfortunately, that sort of money is not available anymore, at least not for this sort of endeavor. So that complicates matters. And to top it off, there's also quite a bit of competition. So again, going back a few years, there's so many different low carbon cement startups that came in, and they kind of all compete with each other for somewhat limited resources. The good thing is that a lot of the bigger cement and concrete companies do want to invest, right? And they do want to work with these people and maybe also later acquire them. So the situation is interesting in that there hasn't been a single one in the last few years which has really, really, really succeeded. Meaning, get towards maybe $400 million of overall value or whatever. But many of them have actually succeeded, to decent levels, meaning they've gotten to a size of maybe around 40 people or something like that. And by the way, we are large in terms of employee size compared to something like AI, right? So they've gotten decent amount of successes, but no one has seen that big unicorn sort of win. So I remain optimistic, and I think with efforts like the Tech Hub, which we'll talk about, I think there is a lot of hope in it working. I don't think there's going to be one solution for low carbon concrete. There'll probably be a lot of different solutions. And I think we are also at the stage where, generally speaking, in many locations, there is this understanding that if the only benefit you can provide is carbon, your solution is not resilient. Meaning, if there's a change in administration or something like that, if all your solution is doing is lowering carbon, your solution may be dead in the water. But if your solution has, multifunctionality, if it has more benefits, if it has
more durability,
or cost, right? I mean, everybody loves cost, right? So if those are also happening, then you're good to go.
But there's also, I mean, one of the ways that cost and carbon could be connected is if we better price carbon.
Correct.
And
yes.
There are a lot of problems, but there are carbon markets. So figuring out ways that can help redirect capital to the true lifetime cost of a project as opposed to just the upfront.
I think again, last couple of years have not necessarily been good in the US to the carbon market, but that's something that could definitely come back. But I think you still run a little bit of a risk
a political risk.
Yes, a political risk.
Yes. Yeah. So you mentioned Tech Hub, so let's talk about it. So you've played an absolutely fundamental role in it's called the South Florida Risk and Resilience Tech Hub. It was funded originally by or almost exclusively by the Economic Development Administration, which is a part of Department of Commerce. We, as a region, collectively won that grant. In full disclosure, I'm on the steering committee, but you've been one of the most active and important members. So talk about what your role has been as part of the Tech Hub and why you see the hub is important and why commercialization is important.
Yeah. So we were one of 31 federally designated tech hubs. And I think we were one of 10 or 12 that won the Phase 2 award. Our award was about $20 million. Others were plus minus a little bit that amount. Some were a bit larger. So the South Florida Risk and Resilience Tech Hub, the overall objective is to encourage economic development. This is not a research project. Its objective is not to do something in the lab, but it's to make a meaningful contribution to South Florida in terms of economic development, in terms of workforce development, enhance security, even national security, improve and advance the startups in the region, contribute to the overall ecosystem of the region. So a lot of these are, very lofty, big picture aims. So we're doing a number of different things to make this happen. So there are 3 projects overall. One is governance, the second is workforce, and the third is the concrete project. So the concrete project is the one that I'm part of, although I also do help with workforce development. So this one is led by Florida International University. And there are a few partners. So Carbon Limit is a partner, Titan America is a partner. So this one overall, we're trying to develop and commercialize a couple of different technologies. So that's one thing that we are all working on. Second, and a big thing is to advance the startup ecosystem. So in theory, high TRL startups, which they've kind of proven out their technology, but they haven't necessarily made a lot of sales, etc. To work with them, to give them either demo projects or to help them through policy, or for example, to put them in touch with VCs or to write grants with them for the federal government. All of those are important. Right.
So these are startups that are ready to move. You said high TRL startups, which are technology readiness levels. It's technologies that are pretty close to being ready for the real world.
Correct. Yeah.
They are ready for the real world. They just need the help, as you said,
They-
policy, investment, business modeling, whatever those things are to get out there. So this is what the Tech Hub is about.
Yeah. We have our own set of technologies. We
Right.
work with startups.
Right.
So there's Titan opened their new innovation hub. Titan or etc. can actually help do a lot of testing for the startups. We have budgeted for that. Then apart from that, there is also this big push to fix. I don't want to use the word fix, but fix policy, right? Because the reason this tech hub is so important is, I should have mentioned this first. The lead organization is actually the county. I can do a lot. Titan America can do a lot, but without the actual support of the county, it's hard to make change happen at in a systematic manner or at that scale. But the fact that the county is actually invested in this is a big thing, because a lot of the policy etc does come from the county itself, and a lot of things like demo projects, for example, the county can make them happen so much more easier than we can, right? I mean, what I can do is, if for example we want to put a new pavement somewhere, right? I can very easily have my people go. We can do a lot of testing, we can do a lot of documentation, we can make videos, we can do all of the testing, but I can't find the land or the region or the concrete for that, right? That's a little bit beyond me. So that's where the county comes in.
Yeah.
And that's where this is such a nice partnership. So it's been a little bit more than a year since we started, and we've done really, really well, in my opinion. I don't think it has transformed South Florida. That may be a bit longer, but I think we can actually kind of see the ecosystem is building. For example, at the CRI conference, so we had this risk and resilience tech hub pitches, and a lot of these different companies were talking, and you could see the synergies, you could see some of the common problems they face, and they got talking to each other as well, which was a nice thing. Among the other things I do, for example, is it's called the Sustainable and Resilient Infrastructure webinar series. We just actually hosted today the 12th one of that series.
Right.
And this was someone that was talking about modularized shipping containers for water, for desalination, things like that.
Right.
We've had 3D printing conversations in the past. We've had conversations from large companies, not necessarily startups. Titan America, for example, gave a presentation.
Right.
They talked about some of their products, some of their offerings, and they also talked about, they showed a digital twin of their plant, of their Pensacola cement plant. So it's not necessarily only cement and concrete.
Yeah.
But the idea is, again, we're trying to talk about the various technologies that are available, broadly either concrete or coastal, but we are open to other technologies as well. We really would want them to have a strong, active presence in South Florida, because that's our focus.
Yeah. And I think you're pointing to something that's important, which is the Tech Hub got funding for concrete and cement materials research, basically, and workforce development, and some startup funds for the Tech Hub. But the ecosystem that continues, whether it's shipping containers or other technologies, has been good, and it feels to me like it's taking the baby steps to developing something. And there's a real innovation ethos in South Florida. I think that's one of the things, for all our strengths and weaknesses here, people come down thinking that innovation, they want to collaborate, and that's pretty powerful.
Yeah. So I mean, with the Tech Hub, right? Like, for example, the nice thing is that it does cover my time, my students' time, and all that. So in theory, if a startup comes up to me and asks me to do a little bit of work, if I'm able to do it, I'm able to do it. I don't care if they focus on concrete or coastal infrastructure or whatever, but if I can help them advance, I will do it, because again, the Tech Hub is covering some of my time. So, it does help in that way. And I think it'll be the same. I don't think we're going to be, this is the narrow definition and this is what we're going to stick to. I don't think that's the spirit of the Tech Hub. At least that's how I've understood it.
Yeah, me too. And I think, the real value of the Tech Hub, I mean, of course, $20 million is real value, but the real value to me is the ecosystem that should lead to a variety of other partnerships and impact.
I mean, the funny thing is, $20 million is a lot of money. but it's also absolutely nothing,
Yeah.
right? I mean, if you go tell Miami-Dade County that you added $20 million to
Right.
their economy, that's
Right.
pocket change, right? I mean, $20 million for an individual person is a big thing, but the tech hub is about, you know, really changing the region. And I think for that, we'll need a lot more than 20 million. But the hope is that this 20 million can catalyze, you know, a lot of different things to make that next step happen.
Yeah.
I really enjoy, you know, the ecosystem here, but I will admit it is very nascent.
Yeah, I agree. And I mean, for me, at least, one goal is to figure out how we can attract more capital allocators of whatever stripe to the ecosystem. And maybe some of that's going to be virtual. We don't need them necessarily to move to Miami. But if you're thinking about resilient infrastructure, this seems to be a place where you should, and you're thinking about investing in resilience infrastructure, this feels like a place that you should do that.
I mean, you know, in many ways, right, I see the role as CRI somewhat similar to my role, but at a much larger scale, meaning through some of these webinars or through working with some of these startups, a big objective is actually just to, you know, make these connections.
Yeah.
You are able to do it at a scale 10x or 100x times I can do it. I mean, you know, the conference you organize, and you should talk about that, right? This just shouldn't be, you know, a one-way thing, but that was amazing. You had 400 people?
Yeah.
And that's just really mind-blowing. I mean, it's such a huge win for the university to have such events, because the big difference with that and with a lot of the things that I do, right, is generally speaking, my impact is going to be pretty local. But the impact of that conference is going to go way beyond South Florida, because you had so many people coming from outside of the region, but also outside of the country. And, you know, these make a lot of different I mean, it's like, you know, it's like seeding a whole bunch of things, right? Maybe some will not lead anywhere, but some will lead to impacts which you'll only figure out in 10 years or something. So I think CRI's role in really, really changing this ecosystem for commercialization or whatever is key.
And that's why we appreciate you coming on the Resilience in Action podcast, because this is partly our way of trying to leverage, you know, the innovation and knowledge we have here with the, you know, exposure that we can provide, so we do collectively create more resilient societies. So I just want to thank you, Prannoy, for coming on. Let me just, before we go, plug the Sustainable and Resilient Infrastructure Seminar Series. It's once a month. Fridays.
Last Friday.
Last Friday of every month, 10 a.m. But you can also find them recorded, right?
All of them are recorded. All of it is on my or the department's YouTube channel.
Yeah.
So
we'll provide a link. And we really appreciate you coming on and for all your work.
It's my pleasure. It's my absolute pleasure, and I think this is closer to the beginning than the end.